Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will be discussing theorems on angles on a circle. So for our first theorem, we have tangent second inscribed angle theorem. So in our theorem, given an angle with its vertex on a circle formed by a secant ray and a tangent ray, the measure of the angle is half the measure of the intercepted arc. So let us examine this theorem. Let's say we have this circle O, and the given is we have a secant ray which is BA, that is a secant ray, and BC as our tangent. So if this is the case, the measure of the angle, so our conclusion, the measure of our angle ABC, angle ABC is, that is the equal sign, half the measure. So half, that is 1/2 of the intercepted arc. So our intercepted arc here is arc AB. AB. That would be our conclusion. Again, this is the tangent second inscribed angle theorem. The measure of the angle is 1/2 of the intercepted arc. Now let us apply this theorem in some exercises. To better understand our theorem, let's have the following examples. We have in number 1, find measure angle 1. So this is our angle 1, given the circle. Number 2, find measure angle 2. This is the angle 2, given the circle. And number 3, find measure angle 3. So this is angle 3 and the given circle. And number 4, find measure angle 4, given the circle. Let us try to find first measure angle 1. So measure angle 1 here. We know that the measure of the angle is half of the intercepted arc. So measure of angle 1 is equal to 1/2 of the intercepted arc. So the intercepted arc is 160. So write 160. So measure angle 1 is equal to 160 divided by 2, that is 80 degrees. So the measure of angle 1 is 80. Next, number 2. Find measure angle 2. If you want to try number 2, pause the video. Then after answering, resume watching to check your answer. Number 2, so measure angle 2 is equal to 1/2 of the intercepted arc. 1/2 of 320. So measure angle 2 is 320 divided by 2, that is 160. So 160 degrees. Okay. Next, find measure angle 3. So angle 3 is located here. So it is half of our intercepted arc. So if you notice that our intercepted arc here is unknown. So we need to find first our intercepted arc. We know that one revolution is equal to 360. So 360 minus 70. So this will give us 290 degrees. So let us check. 290 plus 70, that is 360. One revolution. Now we can get the measure of angle 3. That is 1/2 of the intercepted arc, 290. Now we have 290 divided by 2. That is 145 degrees. Okay, that will be the measure of angle 3. Next, measure angle 4. If you want to try number 4, pause the video, then after answering, resume watching. Let's check number 4. So we have a diameter here. That means this is a semicircle. Semicircle is equal to 180. So the measure of this arc is 60. Why 60? Because 120 plus 60 is equal to 180. That will give us a semicircle. Now we can get the measure angle 4. Measure angle 4 is equal to 1/2 of the intercepted arc, 60. So that is 60 divided by 2, 30 degrees. Okay, so we're done in our numbers 1, 2, 3, and 4. That is the application of our first theorem. Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will continue the theorems on angles on a circle. We have the second one, 2-second interior angle theorem. In our theorem, the measure of an angle formed by 2 seconds of a circle intersecting at a point in the interior of the circle is 1/2 the sum of the arcs intercepted by the vertical angle and its vertical angle. Okay, to better understand, let's have this illustration. We have a circle here, and we have AD and BE are seconds. Intersect at exactly one point, which is the point C. Intersecting at a point, which is the point C here. So we have a vertical angle, this angle, and this angle. In our theorem, vertical angles are congruent. Therefore, the measure of angle ACE is equal to the measure of angle BCD. And of course, this angle is equal to this angle by vertical angle. The measure angle ACB is equal to measure of the angle ECD. ECD. Okay. Now for our conclusion, to get the measure of the angle, let's say measure angle ACE, that is equal to, is 1/2 the sum, so 1/2 the sum of the arcs intercepted by the angle. So ACE, where is ACE? So our arc are AE, so measure of arc AE plus the measure of arc BD. That would be our conclusion. Again, let us repeat. The measure of the angle ACE is half the measure of the sum of its intercepted arcs by the vertical angle. And of course, to get the measure of angle ACB, that is equal to 1/2 of AB, arc AB, plus the measure of arc ED. Okay. And take note, measure angle ACE is equal to the measure of angle BCD. Okay. And this one. Now, to better understand, let's have some exercises regarding this theorem, 2-second interior angle theorem. Now, to better understand our theorem number 2, let's have the following exercises. Find measure angle 5. So, given the circle P and the intercepted arcs, we have 30 and 55, and this is our angle 5. For the second one, find measure angle 6. So, given the circle S, this is our angle 6. Then the intercepted arc, 40 and 52. Let us solve first the first illustration. We're going to find measure angle 5. So the measure angle 5. Measure angle 5. That is, in our theorem, 1/2 the sum of the intercepted arcs. So in this case, we have 30 and 55. So we need to add that. Now, 1/2, 30 plus 55, that is 85. Okay. Now, 85 divided by 2, 85 divided by 2, that is 42.5 degrees. That will be the measure of the angle 5, 42.5 degrees. If you want to try number 6, go ahead, pause the video. Then after answering, resume watching to check your answer. So in our illustration, angle 6 is here. So in the given, we can get the measure of this angle. So let us first find the measure of this angle. So let's name it angle X. So measure of angle X, that is equal to 1/2 of the sum of 40 plus 52. 1/2, 40 plus 52, that is 92. 1/2 of 92, or 92 divided by 2, that is 46 degrees. So this angle measures 46 degrees. Okay. We're going to find the measure of angle 6. So measure angle 6. Notice that the angle 6 and the 46 angle lies in a straight line. So in your grade 7 and grade 8 lesson, there are supplementary angles. So to get angle 6, we need to less 46 to 180. Okay, 180 minus 46. Why? Because the total of the two angles is equal to 180 degrees. They are supplementary, or they form a linear pair. Now, 180 minus 46, that is 134 degrees. So the measure of angle 6 is 134 degrees. So let us check. 134 plus 46, that is 180 degrees. Okay. That is our second theorem. Good day everyone, welcome to Senior Pablo TV. This is our third theorem on angles on a circle. This time we have 2-second exterior angle theorem. So we have 2 second and exterior angle. The theorem stated that the measure of an angle formed by 2 seconds of a circle intersecting at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measures of the intercepted arcs. To better understand the theorem, let's have this circle, which is circle C, and the given, we have AE and second PR, AE and line PR are second. In our theorem, the measure of an angle formed by 2 seconds of a circle intersecting at a point in the exterior of the circle. So this angle, the measure of angle ESR is 1/2 the absolute value of the difference of the measure of the intercepted arcs. So we have the intercepted arcs 2, so we need to get a difference. You have the measure of the arc AP minus the measure of the second arc ER. Okay, that would be our conclusion. Let us repeat. The measure of the angle formed in the exterior of the circle is 1/2 the absolute value of the difference of the 2 intercepted arcs. We have the arc AP minus the arc ER. To better understand this theorem, let's try to solve some exercises. To better understand our third theorem, let's have the following exercises. In our first illustration, we have circle F. Okay, circle F. We're going to find the measure of angle CAD. Where is the angle CAD? CAD. Given the arc CD measures 56 and the arc BE measures 22. And for the second illustration, we have, let us name it circle G. Okay. We have the circle G and the following measurement. We're going to find the measure of X, so X degrees. If you want to try the 2 problems, so go ahead, pause the video. Then after answering, resume watching to check your answers. Let us find the measure of angle CAD. CAD. So in our theorem, the measure of the angle CAD, angle formed in the exterior of the circle, is equal to 1/2 of the difference of its intercepted arc. So we have here 56 minus 22. So 1/2, 56 minus 22, that is 34, right? 56 minus 22, so 6 minus 2, 4, 5 minus 2, 3. 34 divided by 2, that is 17. So 17 degrees. Measure angle CAD is 17 degrees. Okay. Next, find measure angle X. So you study the given circle. In order to use our theorem, the intercepted arcs must be given. So in this case, we don't have the measure of this arc. So first step, we need to find the measure of this arc. We know that 1 revolution is equal to 360 degrees. So we have 100 110. So 100 plus 110, that is 210 plus 80, 290. So 260. 360 minus 290, this will give us 70 degrees. Okay, let's check. 80 plus 70, that is 150. 150 plus 100, 250 plus 110, 360. Okay. Now we have the two arcs. So to find the measure of angle x is equal to 1/2 of the difference, 100, minus 70. So 1/2 of 100 minus 70, that is 30. Now half of 30 is 15 degrees. So measure of the angle x is 15 degrees. So this is 15 degrees. That's the application of our theorem number 3. Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will be discussing two tangent angle theorem. So this will be our fourth theorem. The theorem stated that the measure of an angle formed by two tangents of a circle intersecting at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measures of the intercepted arcs. So we have two tangents. So we're going to use this illustration. We have the given tangent, tangent AS, and tangent RS. So we have a circle C. So they are tangent at circle C. In our theorem, the measure of the angle, here for our conclusion, the measure of angle ASR is 1/2 the absolute value of the difference of the measures of the intercepted arc. So our intercepted arc is APR. So we have the measure of the arc APR minus the measure of arc AR. Again, let us repeat. The measure of the angle formed in the exterior of the circle is 1/2 the measure of the intercepted arcs. We have the APR minus the measure of AR. Now, to better understand, let's try to solve some problems regarding this theorem. Now, to better understand our fourth theorem, let's try to solve the following problems. In our first illustration, we're going to find the measure of angle 1, given the arc 280 degrees. And for our second illustration, we have 60 degrees as our exterior angle. We're going to find x. And in our third illustration, we're going to find the measure of the arc A, B, and C, given the exterior angle. So we're going to apply the theorem number 4 to get the unknowns. So let's try to solve number 1. Find measure angle 1. So angle 1 is here, so we need to find measure angle 1. We know that the measure of the exterior angle is 1/2 of the difference of the intercepted arc. So we have 280 minus, we know that one revolution is equal to 360. So this arc measures 80 degrees. Why? Because 280 plus 80 gives us 360. So 280 minus 80, that would be our arc. So 1/2, 280 minus 80, that is 200. Now to get the measure of angle 1, 200 divided by 2, so this is 100 degrees. Okay. The measure of angle 1 is 100 degrees. Let's proceed in our second problem. We're going to find x, given the exterior angle. In this case, the exterior angle is given. So 60 is equal to 1/2, the exterior angle is equal to 1/2 of the measure of the intercepted arcs, minus. So the bigger one, we can get the bigger arc using the definition. 1 revolution is equal to 360. So if this is x, we can get the measure of the bigger arc. So that is 360 minus x. So 360 minus x, we need to subtract the second arc minus x. So we have 60 is equal to 1/2 of 360. Negative x minus x, that is negative 2x. Okay. Now we have 60 is equal to distribute. So 1/2 times 360, basically that is 360 divided by 2, so 180. Minus 1/2 times negative 2x, that is negative x. Now x is equal to 180 minus 60. So x is equal to 180 minus 60, we have 120. So the value of x here is 120. So x is equal to 120. Now to get the measure of the bigger arc, so 360 minus 120, that will give you 240 degrees. And for our third problem, we need to find the measure of arc ABC, given the exterior angle, which is 34. So the exterior angle, 34, is equal to 1/2 of the difference of the intercepted arcs. So in this case, we don't have a measurement for this, so we're going to assign AC as our, let's use the variable A. So AC will be our A. Therefore, the bigger arc is equal to 360 minus A. If you want to use X, that's okay. You want to use B, okay. So we have 360 minus A minus A. The same process with number 2. We're going to find the value of A first. So we have 34 is equal to 1/2 times 360, negative A minus A, negative 2A. So 34 is equal to 1/2 times 360, so that is 180, minus 1/2 times 2A, that is A. So we have A is equal to 180 minus 34. So our A is 130 minus 34, that is 100. 146 is the value of A. We're going to find ABC, the arc ABC. So we need to subtract 360 minus 146. So 4, this is 5. 5 minus 4, 1. So 214. The measure of arc ABC is equal to 214. Okay, so 214 plus 146, it should give us 360 degrees, one revolution. So that's the application of our theorem number 4. Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will be discussing tangent second exterior angle theorem. So the theorem stated that the measure of an angle formed by a tangent and a secant of a circle intersecting at a point in the exterior of the circle is 1/2 the absolute value of the difference of the measures of the intercepted arc. So it's just like the same as the tangent or two tangent exterior angle theorem. To better understand, let's have this illustration. So we have a circle and PE is a secant and RE is a tangent. So the measure of the exterior angle, let's say measure of angle AER, so the measure of the angle formed by a tangent and a secant intersecting at a point in the exterior of the circle. So this is the angle, measure AER, is the equal sign 1/2 the absolute value of the difference of the measures of the intercepted arc. So we have the arc, measure of arc PR minus the measure of the arc AR. Okay, that would be our conclusion. The measure of the exterior angle is equal to 1/2 of the measure of the intercepted arcs. The difference of the intercepted arc, PR minus AR. To better understand this theorem, let's try to solve some problems regarding this theorem. To better understand our theorem, let's try to solve the following problems. So in this case, we're going to find the angle 1, and in our second illustration, we're going to find the angle 2. So let's try to solve first angle 1. So the measure of the angle 1, the exterior angle. So 1/2 of the difference of the intercepted arcs. We have 210 minus, we're going to find the measure of this arc. So 210 plus 100, that is 310. So we have here 50 degrees. Why 50? Because one revolution is equal to 360. So 50. Now we have 1/2, 210 minus 50. So we have 160. To get the measure of angle 1, half of 160, we have 80 degrees. That will be the measure of angle 1, 80. Now let us proceed in our second example or second problem. We're going to find the measure of angle 2. So let's say this is 50 degrees. Okay. First, find the measure of the intercepted arcs. So we have 190 and 50. That will give us 240. So this is 120 degrees. We can now get the measure of angle 2. That is 1/2 of 120 minus 50. So 1/2 of 120 minus 50, that is 70. Now half of 70 is 35 degrees. So that's the application of our theorem number 4. Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will be discussing two-chord intersecting theorem. So if two chords intersect in the interior of a circle, the product of the length of the segments of one chord is equal to the product of the lengths of the other chord. Now let us illustrate. So we have a circle here, then we have two chords, the first one and the second one. The product of the length of the segments of one chord, so the product, let's say A times B, is equal to the product of the length of the other chord. So A times B is equal to C times D. This will be our formula. A times B is equal to C times D. Now let us apply this theorem to solve some problems. Now let us solve the following problems. Find x given the circle and the chords. We have AC and BE. So solving x, so we have the theorem A times B, or AB times BC is equal to BD times BE. Okay, this is our formula according in our theorem. So substitute AB, the measure is 6, times BC, that is x, is equal to BD, which is 3, times BE, which is 8. 6 times x, we have 6x is equal to 3 times 8, 24. Divide by 6, x is equal to 6, 12, 18, 24. 4. That will be the value of our x. Now, solve for x again. If you want to try, pause the video, then after answering, resume watching to check your answer. Let's try to use the shortcut. So we have 18 times x is equal to 15 times 12. So we have 18x is equal to 15 times 12, that is 180. So divide by 18, x is equal to 10. That would be the value of our x. So that's the application in our theorem number 6. Good day everyone, welcome to Senior Pablo TV. And for today's tutorial video, we will be discussing 2-second segment theorem. So it states that if 2-second segments are drawn from the same exterior point, then the product of the length of 1 second and its external segment is equal to the product of the length of the other second segment and its external segment. So notice in our theorem we have 2-second segment. So to better understand, let's have this illustration. We have a 2-second, 1 and 2. Then the product of the length of 1 second, so let's say our first second is W, and its external segment, so this is our second, and its external is x. So W times x is equal to the product of the length of the other second segment. The other second segment, which is, say, times the external segment. The external is y. That would be our formula in the given theorem. Again, let us repeat. the first second segment times its external part is equal to the second segment times the external part of the segment. So that's the 2-second segment theorem. We're going to apply this theorem to solve some problems. Now, to better understand our theorem, let's have this problem. We're going to find x given the circle and the 2 second. So in our theorem, the length of the other segment, so we have 6, we're going to add 4x, this will be the total length of the first segment, times its external part. The external part is 6, which is 6. Again, let us repeat. So the length of other segment, that give us 6 plus 4x, the total length of the second, times the external part, which is 6, is equal to the total length of the other second segment, that is 6. We're going to add x plus 3 times the external part, which is 6. Now distribute 6 times 6, that is 36. 6 times positive 4x, positive 24x, is equal to 6 times add 9 plus 3, 6 plus 3, that is 9 plus x. Okay. So we have 36 plus 24x, 9 times 6, that is 9, 18, 27, 36, 45, 54, plus 6 times x, that is 6x. Solving for x, so we have 24x minus 6x is equal to 54 minus 36. Now we have 18x is equal to 54 minus 36. That is 18. To find x, we need to divide by 18. So x is equal to 18 divided by 18, that is 1. Okay. So the value of our x is 1. Tangent second segment theorem. If a tangent and a second segment are drawn from the same exterior point, then the square of the length of a tangent segment is equal to the product of the length of the other second segment and its external segment. To illustrate our theorem, let's say we have this circle, then we have a tangent segment and a second segment. The square of the length of a tangent segment, so our tangent segment here is q, so q square is equal to the product of the length of the other second segment, the product of the length of the other second segment, which is s, the total length, times its external segment. Its external is r, s times r. So if the given is a tangent and a second, so square of a tangent segment is equal to the total length of the second times its exterior part. Let us try to solve some exercises regarding this theorem. Now to apply our theorem, let's have this problem. Our example number 1, we need to find x. So we have a tangent segment which measures x and the second segment 7 and the external part is 9. So following our theorem, square of the tangent segment is equal to the total segment of the second is 9 plus 7 times the external part, which is 9. So x squared is equal to 9 times 9 plus 7, which is 16. So x squared is equal to 9 times 16, that is 144. Get the square root, so x is equal to 12. Our second example, find x. So you study the circle. We have a tangent segment and a secant segment. So x is located here. So following our theorem, we have the tangent segment. So 18 square is equal to the total length. The total length is 15 plus x times the external part, which is 15. Okay, this time we need to use the calculator. 18 times 18, or 18 square. This is 324 is equal to 15 times 15. That is 225 plus 15 times x, 15x. So 324 minus 225 is equal to 15x. So subtract. That is 99 is equal to 15x. To find x, we need to divide by 15. So x is equal to 99 divided by 15. That is 6.6. So x is 6.6. So that's the application of our theorem.